Incidentally, in MathCAD, should you, and probably in Mathematica as well, I've only looked at Mathematica a couple of times. In MathCAD, there are several different equal signs that mean different things. It's easier to understand them if you've ever programmed. Anybody ever programmed in even something as simple as QBasic or Visual Basic or C++ or Fortran? Now you're showing your age. If you programmed in anything.
All the above.
All of the above. If you programmed in all of the above, one of the things that, and if you also date back a really long time, computers used to read strings of commands one line at a time. You couldn't just write things all over the screen wherever you wanted and expect you to understand it. You had to read one line at a time. So in the computer, when you did things like write a line that said x is equal to 2, the way the computer read that was that the number 2 is being assigned to the memory location x. X has been defined as the number 2. So in MathCAD, the symbol colon followed by an equal sign is an assignment operator. Did you learn to program in APL ever? No. Okay. APL was the first symbolic programming language many years ago, a couple of decades ago, maybe, I don't know, about 30 years ago or more. There was, in those days of mainframe processing, and those of us who were really racy were using teletype consoles, and so they interpreted everything line by line. Well, APL was a symbolic programming language that could interpret line by line. It was really incredible for that day. Now it's like Model T Ford. So the colon followed by an equal sign is an assignment operator. And so 1 over 66,000 times the transpose of the cofactors has been assigned to that variable name. A regular equal sign is the way you coerce MathCAD to revealing to you the number that's stored in a symbol. This would be an example. So here I wrote XTX inverse, and I just typed the equal key, and it revealed to me the numbers that were stored in XTX inverse. The third kind of equal sign is up here, where I used that tricky little device to avoid rewriting a bunch of tedious arithmetic. This equal sign is a little heavier. It's a boldface equal sign. And that is a logic operator. It's a Boolean equal sign. And this says that these things are equivalent to 0. Not equal to 0, but in logical or Boolean constructs, this and the number 0 are equivalent forms. And so you could do an if. An if test, an if statement in Excel and other software packages like that is a Boolean operator. It says if the following statement is true, return this answer. And so in the routines that take your set of Boolean equations, it plugs numbers in here, trial numbers, and it looks to see whether or not the left-hand side is logically equivalent to the right-hand side. So there are 3 different kinds of equal signs in MathCAD, depending on what you're trying to do. And actually, there's a fourth operator that, depending on what you're doing, can be interpreted as a 4th kind of equal sign. And I'll show you what that is in a second. Oh, I don't have my computer turned on, so I can't show you. Okay, so let's come back here. So now we've got X transpose X inverse here, and I've told MathCAD, tell me what's actually there. I want to see the numbers, because I wanted to see if you guys had the same numbers. And then I said, okay, beta hat is equal to X transpose X inverse times X transpose Y. We computed this, and we were given that, and so the regression coefficients turned out to be 4, minus 0.2, and 1.6. And then we need the variance of the error term, the variance of U. The question that naturally comes up is whether or not we've had enough information. We had said that our estimator for the variance of the error term was going to be 1 over n minus k times y minus x beta hat transpose y minus x beta hat. So you had to get from that to the information that you did have. One of the other things that we know is that sigma hat squared is equal to the residual sum of squares over n minus k. And another piece of information that we have is that the total sum of squares is is equal to the explained sum of squares plus the residual sum of squares. So if we can figure out the total sum of squares, and we can figure out the explained sum of squares, we know the residual sum of squares, and then we know sigma hat squared. So did we have enough information? Well, yeah, because the total sum of squares is equal to the sum of the yi squared. The explained sum of squares is beta hat transpose x, x transpose x inverse, x transpose y. I suppose x happens to be true, but beta hat. Or wait a second, yeah. Beta hat was y prime x. I got too many. One. So do we know all these? Sure. You know x transpose y, you know x transpose x inverse, you know x transpose x. So, and you can even take advantage of the fact that those two cancel. So now you got a few less complications to do. So there are many ways to skin this particular cat, depending on which pieces of information you choose to pull in. Because if you look at what we were given to start, one of the things that we were given was the sum of the yi squared, yi minus y bar squared is equal to 150. And one of the things that we know is that that's the same as the sum of the yi squared minus ny bar squared is equal to 150. Do you know y bar? It's knowable from what you were given, because the first entry in x transpose y is going to be the sum of the yi. Divide by 33, you got y bar. And solving for sum of the yi squared is, again, a simple thing. So there are all kinds of different ways you can go through manipulating the given information to come up with sigma hat squared. And that's one way to do it. So sigma hat squared is 0.253. And once you've got sigma hat squared, it's easy to come up with the coefficient covariance matrix. The coefficient covariance matrix, by definition, is just sigma squared hat times x transpose x inverse. You already figured out x transpose x inverse. You already figured out sigma squared hat. And so now you've got the coefficient covariance matrix. In part E, you're asked to test a hypothesis about alpha 2 against the alternate that it is not 0. Two-tailed test, 32 degrees of freedom. And the corresponding t-statistic is minus 2.042 and 2.042. Those are the critical values. You can construct your test statistic as your estimate of beta 2 divided by the standard error of your estimator, which is the row 2, column 2 element out of the coefficient covariance matrix. And since the observed t is gigantic, you reject the null hypothesis. And then in the second one, you had to test a hypothesis about a linear combination of the coefficients. So I said, because I had been using alphas and a's elsewhere, I said, let's define a vector gamma, which has a 0, 2, and a 1 in it. And gamma transpose times beta hat is the random variable we're asking something about. And the observed value for that random variable that we're asking something about is 1.2. And the variance of that random variable is gamma transpose times the covariance of beta hat times gamma, and that turns out to be 0.025. So this is 4 times the variance of, in the notation used in the exam, this would be 4 times the variance of A1 plus 1 times the variance of A2 plus 2 times 4 times the covariance between A1 and A2. So it's just picking off the elements out of the covariance and covariance matrix of beta hat. And your t-statistic for this linear combination is 7.5, and that's a big number. Then you have to look up our critical value to know that that's a big number. You would reject the number. Okay. Any questions? Yes. Mike, come in. Nicole. Oh yeah. Hillary, you can have your test. Ron, why are you hiding back there in the corner? Coefficient covariance matrix? Well, you start from the definition. equation squared half times x transpose x inverse. That's just a definition. This is connected to the website, by the way, in the syllabus. And it's because I've turned it into an RTF file. You can open it with Word. Any Word will open an RTF file. What does RTF stand for? Rich text format. Yeah, so all the word processors can open an RTF file. Any questions? Anybody? Yes. Oh yeah. Okay. So there's a -1 in here, but I don't think anybody has that anyway. Jeremy had it, so nobody else in the class got that one. But you're right. There is supposed to be -1. I think. So it's yeah. I missed that. Anybody else? No. Okay. We're going to do a couple of more homework assignments before the end of the semester. You have a final exam, and you have a research paper that you're working on. So there's still lots of graded work to be done. Oh, I had one other thing that I wanted to... Whoa, will you look at that? Question 5 on the past exam that I posted to the website. Exactly like question 5 on this exam.
That was a lot easier.
This one was easier?
Yes. Much easier. That one is much easier. Can we do this again?
From the following information on the data cross products, calculate the regression coefficient. Yeah, but the rest follows from being able to do that.
This one can be finished within 2 minutes.
Well, I hate to tell you this, but a fair proportion of people in the class would have struggled with 5 on this exam. And you didn't have to do 6. 3 and 4 were similar to what I gave you. I can tell you from the experience the semester that I gave this, more than half the class struggled with question 2 on this. This was much harder than the distribution question you guys got. Or I guess I didn't put one on. Most people, when I used this question, most people did not get that. And 1 you should be able to do, no problem. Okay? So let's, and there, in addition, without looking through all this stuff. Okay, let's leave it at that. Let's talk about generalized least squares, unless there are other questions or complaints. So, that's next week, yes. So I need you already got yours done. Right. So an outline is due next week. An example of one you can find by clicking on example. Let me strongly encourage you to click on example. See how carefully it's done? There are rules for outlining or constructing outlines, very formal rules, and I expect them to be followed. Doing an outline is not the same as writing the paper. As long as the numbering scheme that you use changes with the indents and remains consistent across the major headings, you can use whatever numbers you like. But I don't want to see a rough draft of your paper in lieu of an outline. I want to see an outline. So the headings, Karen was going to talk about uncoordinated policies in the very first paragraph of her introduction. She didn't discuss uncoordinated policies in what she gave me. She just said, this is what's going to appear in that corresponding paragraph of my outline. And in the next major part of her introduction, and she might, in the final paper, she might have only had 2 or 3 sentences about uncoordinated policies or explaining what they are. In the next major section, she was going to explain the different ESP options. She didn't do that. Instead, she enumerated how she was going to deal with them. So let me encourage you again to take a look at the way she did her outline. She really did a superb job. Is there value in writing outlines? Oh yeah, because most people can't write off the top of their head in a coherent form that has flow to it. Two of my very dear colleagues in the department, with whom I've written many papers, Professor Hakim and Blackstone, after all these years, still refuse to put together an outline before they sit down to write. And they write, and they rewrite, and they rewrite, and they rewrite, and they rewrite, as they try to bring some organization and coherence to the paper that they're writing. If you just write an outline, you can avoid a lot of rewrites as you're trying to get the organization right. and the coherence work. It helps you clarify your own thinking and what it is you want to accomplish in the paper. And if you do an outline, the person who reads your paper, if they were to outline the paper that you eventually write, they would come up with exactly the same outline that you had prepared for yourself. So at one point, I was having a big dispute with Hakeem and Blackstone about a paper we were working on. And I said, this is my interpretation of the paper that we've written. And they said, no, you're wrong. This is a paper that the three of us wrote together. And I said, my interpretation of the paper that we have before us is apparently a variance of the paper that you guys think we wrote. What I'm going to do is I'm going to go home and I'm going to write an outline from the paper that we've written. And I'll show you the outline, and you tell me whether or not that's the paper that's the outline that you had in mind, that's the proposed paper. Sure enough, the outline that I put together from the paper that we had written jointly was different from what was in their mind when they did the very first draft. So outlines are extremely valuable. And there was a reason that Mrs. Harrower in the 3rd grade made you learn how to do outlines.
Is there a reason why, what's the reason for section G, the fifth section?
Calculations of EFC?
No. Big V, the big section. Tables. If you scroll down, she puts her tables at the end.
That's,
Wouldn't you want that in the...
How many of you have read journal articles? Professional journal, not law school articles. I mean the real thing. So, when you read a journal article, the tables appear in line. Many journals, when you submit a paper, ask that the tables be accumulated at the end so that the compositor, when they put the articles together for typesetting, can put them in where it's most convenient for them to put them in. And we're just supposed to show kind of indication in the text where the table would go. And so she was just trying to adhere to that convention. So you're accustomed to seeing the articles where the tables are embedded in the text, although many journals who submit will ask that you do things like put all the footnotes at the end, put all the tables at the end, and that way it helps the compositor, if you get to that point, figure out how to assemble the finished product on the printed page. When you submit a paper to me, you can do it either way. You can put them in the tables in line, or you can put them at the end. You can put the footnotes at the bottom of the pages, or you can put them at the end. To be truthful, my personal preference is to see the footnotes at the bottom of the page. I like footnotes. If you didn't include if the information wasn't important, you wouldn't have included it. So when I read a book that has a lot of footnotes in it, it drives me nuts to have my thumb in the page that I'm trying to read while I'm looking in the back to find the footnote to see if there's something interesting. So my suggestion is just put the footnotes at the end of the bottom of the page. And with Word, it's easy to flip-flop back and forth. If you like them at the end for another purpose, it's a button push in Word. If you want to put your tables in line, that's great. Sometimes that makes printing your paper a little bit difficult. So oftentimes it's better to put a table on its own page and then just have the page follow the page on which you refer to it. So then the reader is just turning back and forth one page instead of trying to find them at the very end. Okay.
Same for graphs in there or...
Yeah. Put them on their own page and try to put them on a page near where you refer to them so that there's not a lot of hunting. So I don't need to use Google Maps to find the tables and the graphs. So an outline is due next week. Let's take 5 minutes, and then we're going to talk about GLS, generalized least squares.